So in this example, we have another right triangle. We know one angle other than the right angle. We know one side, and we're trying to find two other sides. So as always, let's begin by labeling the different sides. So if this is the right angle up here in this corner, then the side that's opposite that is the hypotenuse. So that's where the 5 is. The 5 is the hypotenuse. Okay. The angle that we are the angle that we know is the 30-degree angle. So if we know the 30-degree angle, let's draw a little arrow away from it. And the side that that arrow points to is the opposite. So B is the opposite. And then the third side is going to be the adjacent. So this is the adjacent over here. So your first step should always be to label the three sides. Now, before we get on to finding the two sides, we do have a missing angle as well. And that's actually easy to do, because to find the missing angle, all we need to do is make sure that the three angles together add up to 180 degrees. Okay? So the three angles together have to add up to 180 degrees. Those three angles are the 90 and the 30 and this unknown angle here, which is angle A. So that's 180. If we want to get the A on its own, the 90 and the 30 are in the wrong place. So take away each of those from 180. And that gives us 60 degrees. 180 minus 90 is 90. Take away 30 is 60. So 60 is equal to A. So that's the first thing done. Okay, so we find the missing angle. Now let's try and find the missing side. Okay, and we can decide whichever one we want to find first. Let's go take these in alphabetical order to find side A. Okay, well, we know the hypotenuse. We know the hypotenuse is equal to 5, and we want A, and A, we said, if we look at this, A is the adjacent. We want A, the adjacent. So if you think about which ratio involves a hypotenuse and adjacent, it's going to be, we're going to use cosine. Cosine uses adjacent and hypotenuse. Cosine of the angle that you know, which is 30. I know we know the other angle as well, but since we define the angles in terms of cosine of 30 degrees, that's what we're going to use. So let's use cosine of 30. So we know that the cosine of 30 degrees is equal to the is equal to the adjacent, which is A, over the hypotenuse, which is 5. Okay, so cosine of 30 degrees equals A over 5. Now, what we could do is what we will do actually is we'll multiply both sides of this equation by 5. Okay, just to be consistent. We've done this before. Whenever you have an equation that involves a fraction, you can multiply both sides by the bottom of the fraction. So that gives you 5 cosine 30. And what happens on this side is the 5's cancel out, is equal to A. Now, in the previous example, we used the calculator here to look up cosine of 30. But this question, if you look at it again carefully, said without using the calculator. Now you can only do a certain number of these without using the calculator, but 30 degrees happens to be one of those types of questions you can do. And what we're going to do, we're going to copy in this table from your notes, and if you look at this, here's 30 degrees here. Okay, here's 30 degrees. Okay, and if we look up cosine of 30 degrees, it's root 3 over 2. Okay, cosine of 30 degrees is root 3 over 2. So if we bring that up here now, that means we have 5 times root 3 over 2 is equal to A. And that's actually our answer, 5 root 3 over 2. Okay, 5 root 3 over 2. And that is the precise answer. It's a better answer than your calculator can give you if you did look it up. So that's the angle. That's the answer for side A. Okay, let's move on and look at side B now. Okay, find side B. And if we go back and we look at our diagram again, it's been a little bit of time, so let's go back and look at our diagram. We know the hypotenuse is 5. We want side B, which is the opposite. So, okay, so we know the hypotenuse. We know the hypotenuse, which is equal to 5. And we want side B, which is the opposite. So you're trying to think what ratio involves hypotenuse and opposite, and it's sine. So we're going to use sine of 30 degrees because hypotenuse and opposite are the two sides that are involved here, and they're both used in the sine. So let's write out the sine relationship. So sine of 30 degrees is going to be the opposite, which is b, over the hypotenuse, which is 5. Okay. Now, just like we did before, in an equation with a fraction in it, multiply both sides by the bottom of the fraction. So we multiply both sides by the bottom of the fraction, that's 5, and we get 5 sine 30 is equal to b. 5's cancel out. Again, we're not going to use a calculator here, so to look up sine 30, we can use the table. So it's going to be 5 times sine, here's 30 degrees, sine of 30 is 1/2. So it's going to be 5 times 1/2 is equal to b. So that means b is equal to 5/2. 5 over 2, 2.5. b is equal to 2 and 1/2. Okay, and since there were no units given in the original triangle, there are no units here. But it could be centimeters, could be inches, could be feet, any unit of length. Okay. So, certain angles that we need to be able to look up in this table: 0, 30, 45, 60, 90. And we can solve questions without a calculator if they involve those angles. If there are any other angles other than 30, 45, 60, 90, or 0, we will have to look up the calculator to get our answer. But for 0, 30, 45, 60, 90, we can look up the sine, cosine, and tan of each of those angles on this table. And this is the table you need to learn. Okay?